So today we are going to start a new topic which we call circular motion. Circular motion, okay, not circular functions. Circular motion. So circular motion has two things. One is horizontal circular motion. The other one is vertical circular motion. Okay. Horizontal circular motion, vertical circular motion. This is my first one. This is my second. So let me discuss horizontal circular motion first. Horizontal circular motion looks like this. Like this. This is 90. This is M. Yeah. There is a velocity here. There is a tension here. This angle is theta. Now we'll understand the logic, okay? We'll understand the logic. Horizontal circular motion is like this. If I do this, right, no motion, then you understand m here, mg goes down. Mg is equal to t. That you understand. Here, this situation, mg is equal to t, right? What do you have here? Force balance. T is here, mg is force balance. Now what I am going to do? What is that? Horizontal circular motion. Why? Because the object is horizontally moving. Horizontally moving means it is moving on a horizontal plane. That plane. Right? So that is something. That is one thing. Vertical one is now I can do that like this. This too heavy, like this. Right? Like a merry-go-round. Not a merry-go-round. What do you call it? Roller coaster. What do you call it? Huh? What do you call it?
Is it Ferris?
Hmm?
Like that.
Yeah, that, like that. What do you call that?
Ferris.
We have one in the city, the
Yeah.
Docklands.
Yeah,
Ferris wheel.
What we?
Ferris wheel.
Okay, whatever. Okay. So it's a vertical circular motion, right? So now first of all we'll understand this. Okay. Now we'll understand the physics here. If you understand the physics, math is easy. Okay. So if you do that, so here you can see T is equal to mg. That is only force, only physical thing you can think about. And if you do that, what do you understand now? There is a velocity, right? That velocity is this. Understand clearly? I will teach you clearly. You have to understand, absorb it, and keep it clearly. Okay? Like one of my students who's doing 3 subjects with me and then performing like that, and others are not performing like that. What is the problem, right? There shouldn't be a problem. So if I do that, now you can see V. Now doesn't matter what situation, you can be here, it can be here, it can be here, it can be here, like that. Suppose it is in this situation, right? While it is doing that, it is in this situation, right? I'm going to show you. Then what will happen? Like that, right? So the next instant would be this tries to move this direction, right? Like that, right? So there you have velocity v. Now where is mg here? Mg is always down, right? Always vertical, like that. Then what is T? Yeah, if you have a tension, if you have a rope, you have a tension, right? That is that, right? Mg is that, right? Obvious, right? So then what is the angle here? Yeah, because it's not like that, it's like that, right? So when you are doing this, there is a certain angle, right? If you do more, see, you can change the angle too, right? So angle can be changed. Then if you change the angle, this object might go here and then do a small circle. If this angle is greater, this might go here and make a large circle, right? But when you do that, you will see that mg and t, they would be the same. Why? Because mg and t would be the same. What about v? V is not the same. Why? Because if you do slowly, it will be like that. If you do fast, see, it's more faster, it's more. So that means angle is increasing or decreasing, right, with velocity, right? Practically that is happening. Okay, so that's all about the physics. Now we'll try to understand the math part. Okay. So now we'll discuss. Look, this is the object, right? Now, this is how we have to attack the problem. To have a circular motion, right? To have a circular motion, these things are there. I'll show you a few things. Now this T, this is a force, right? Velocity is not a force, right? I'm going to resolve this T. If I resolve this T, it would be T1. Towards the angle, it would be cos. You remember that word, towards the angle cos in projectile motion? These things, these people can remember, it's in their blood. If it is not in your blood, change your diet. Otherwise, what to say, yeah? Change your diet. So, T cos theta. Any questions there? What I did, I resolved the forces, right? So, these are vertical. Now, vertically, what you are expecting? Vertically, what you are expecting? Vertical force balance we are expecting. Why vertical force balance we are expecting? Vertically, when it is moving like that, we are expecting a vertical force balance. Why? Otherwise, instead of doing this will do like this, roller coaster type of a circle. Right? It is not jumping and going on a circle, right? It's just smoothly going like that. Right? It is not like that, right? So, if it is going smooth like that, circular motion, smooth like that, that means vertically, there is no external force. That means whatever the force you have here should balance with the force down. Make sense? Okay. So, vertical force balance. I'm just showing you the logic here, right? So once you know the logic, you can make the equations. So vertical force balance, T sin theta is equal to mg. All good? Right? Okay. So what about the horizontal force component? What about the horizontal force component? What about the horizontal force component? T cos theta, right? So, is there any force away from that, that means in the right hand side, to cancel that T cos theta? No, I can't see it. Right? So there is no force that way, right? So that means if you think about horizontally, right? If you think about horizontally, this T cos theta is the only force you have horizontally, yeah? So if you have T cos theta, horizontal force, right? T cos theta, if you have that, do you have horizontal force balance? Understand? No horizontal force balance. Why? Because there is only one force, right? So no force balance in horizontal direction. Okay. Okay. No force balance in horizontal direction. So if there is no force balance in horizontal direction, what we are expecting? Okay. So, you understand? So in the horizontal direction, you have only one force, which is T cos theta. That means what? That means in horizontal direction, you have an external force. So I would say F external force in the horizontal direction is equal to T times cosine theta. T cosine theta. All good. Now, if you have a external force, what will happen? If you have external force, what will happen? Say it again. That means you use F is equal. Now we use F is equal MA. I'll give you a proper note next time, but same thing I will properly write. F is equal to MA. Where I'm going to use it? See, these are important. See, where I'm using it. F is equal to MA. In which direction we use F is equal to MA? Say it again. Towards the center. Why? Because you can see T cos theta is towards the center, right? See? Yeah? Towards the center. So, F would be now T cos theta M. A is called AR. Okay, any questions? This AR is called radial acceleration. This AR is called radial acceleration. Right? Why we call radial acceleration? You can see it is radially inward. Okay? Keep this in your blood now. Keep that in your blood. Okay? Okay? So this AR, I will teach you that later. This AR is given by V squared divided by R. R means the radius here. Okay, just write it down for now. So you will get from here T cos theta is equal to M V squared divided by R, and that would be the relation you get. So you get two relations, one is this, one is that. That's all about the details. That part also I described. but we will again go through next week and then finish vertical as well. Now I want you to rectify this paper, do it properly, understand your mistake. I might check you with a different question next week. You never know, right? Because I need to give you the right training, right? So I will do that. I'm dedicating to do that. So rectify it. Rectify means like not looking at the thing and doing it, right? Rectifying means you understand the concept first and then you reattempt it. Rectification means not copy pasting from your book to here. Okay? That's how everybody improve. Okay guys? Any questions? So do that because I can finish the syllabus next week. But the thing is, if you are going like this with holes, I mean no point, right? So we'll fix one by one and then move. Okay guys? Okay. So I was small bit. Guys,
That's what I thought. I'm like, I don't understand. It's just going to be
so all of you got the paper? All of you got the paper? There should be no. Okay. Now, while we are doing this theory, so today I am going to I'll try my best to finish exponentials and log, but I need to give you the right understanding as well at the same time. Now, these are our previous stuff, right? So, show me your colors. Show me that you know how to do these things, and then I'll take over.